So we want to introduce a new data type, similar to int and float that we've used before. It's called character, and it's abbreviated CHAR. So sometimes you'll hear me say char. Uh, it's a small integer. Regular integers are 16 bits. This is only half the size. It can only hold numbers from 0 to 255. It's most often used with the ASCII table, which we'll talk about in a moment. But it's just an ordinary set of memory, an integer, just smaller than usual. So you can do all sorts of calculations that you would have before. So I'm going to build this and we'll see what PuTTY gives us. Okay. There's programming and waiting for enter. And you can see it prints the numbers. It does the calculations as we expected. Don't know why I have that there. Let me get rid of that. Now, where this usually is much more useful, and the why it's called character instead of something like small int, is the fact that it's used to represent characters from the ASCII table. Okay, so let me call up the ASCII table. And the ASCII table is a set that has all the numbers from 0 to 255. I'm not showing all of them here. But for instance, the capital letter A, that's ASCII 65. And so if I look back here, that little symbol, variable A, is actually would give me this character A from the ASCII table. The way you tell the program that you want the value from the ASCII table is you use a new format specifier. Instead of talking about integers, you talk about characters again. So now we have %C, 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 %C. Let's build this and see what we get. Okay, so we hit enter. Okay, so here's the ASCII values. Here are the, oh, boy. Let me try that again here. %C is the same as %U. My typing sucks big time. So %C, %C. Build it again. Sorry about that. And look at this. Okay, so when I hit enter, you can now see what the symbols are. So 65, as we said, was capital A. 98 is a lowercase b. C is the ASCII 54 is the symbol 6, not the number 6. Can't stress that too much. Symbols and numbers are not the same thing. And 36 is $sign. So if I call up the ASCII table, you can see right here, 36 is the $sign. Now, you're not going to memorize the ASCII table. What we would typically do is learn to rate them in a way that's useful to us. So I wanted C to be, let's see, what did I want C to be? 54 and D to be 36. So what you would do is you would use single quotes, not double quotes. Double quotes will cause an error. And you put single quotes next to any character you can type on the board. Okay. We do that, and we build again. And we look. You'll see that these numbers are correct and the symbols print out. Okay, so this means you don't have to memorize the ASCII table, but you must remember to use single quotes. That's perfect. There's this bit about the single quotes and the difference between symbols and numbers is super important. Suppose, for instance, I said, if C is equal to 6, and ... C represents this quantity that we have. It's a number, and that number was 54. 54 is not 6. If you want to see if the number in the ASCII chart corresponds to 6, then you'd have to put in quotes right here. That's a common mistake, and you have to keep that in mind. Now, if we look at the ASCII table, there are these first 30, 31 characters which are non-printing. This one is also non-printing, but it's the blank, the space bar. Right? So we have all these characters. What do we do with them? Well, for the most part, we ignore them. We don't make use of many of these. But there are several that we do use. One of them is the escape, which is 27, and the carriage return, which we use represents the enter key. So if I wanted to use those, I would have to say something like C equals 13. Semicolon. This is the enter, right? And D equal to 27 is escape on the keyboard. There are no little shortcut, there's no symbol for enter and escape other than CR and ESC. So let's see what happens when we work with these guys. So just have to make sure I'm not in the simulator. Apply. Okay. Let's build and load. Okay. And you can see here that it's got 13 and 27. The 13 is the new line, and it just caused this line to stop. So we're not going to be printing these guys out much, but when we're looking at the next section, when we're looking at keyboard input, we're going to be interested if somebody hits enter or escape. Thank you for now.